In this video, we are going to see about the operation of circular doubly linked list. So the first operation we are going to see here is the insertion. And insertion, we are going to see two different cases for doing the insertion. One is inserting the new node at the beginning, and second one is inserting the new node at the end. Okay. So first we will see insert the new node at the beginning. Okay. So this is the sample circular doubly linked list we have taken. So here what we will do means we will check the condition. Okay. So here what we are going to do is we are going to check one condition. Okay. So that condition is we have to find which is the start node. Okay, after finding the start node, before that node what we will do, we will insert the element. So here what condition we will check is ptr tends to next is not equal to start. Okay, we will check this condition. It is a while loop, and inside this while loop what we will do, we will check the condition. If this condition is true means we have to execute the statement, that is ptr is equal to ptr tends to next. Till this condition getting false, what we will execute. So once we get the we will find the, if we find the start node, what we will do, we will insert the node here, okay, at the beginning. And what we have to do, we have to change the address part. So what will happen in this part, previous, the next part, it contains the address of this node, and here it contains the address of this node, and in a last node it contains address of this first node. Okay. We will see the algorithm. So this is the algorithm. Okay, so we will see with this algorithm. So first we are checking the overflow condition. So that is for, we are checking whether the memory space is available to do the insertion. Okay, then what we are doing, we are creating the new node. Okay, then we are allocating the memory space for the new node. Okay, after that what we are doing, we are assigning the value. So for example, consider this is the new node I'm representing here itself. Okay, then I'm giving the address as a 6, value as a 6. So we have assigned new node tends to data is equal to value. So we have given the value. Next what we are doing, we are assigning ptr is equal to start. Okay, we are assigning ptr is equal to start. So this is the start node, so we are assigning this as a ptr node. Then we have to check the condition while ptr tends to next is not equal to start. Okay, we have to check the condition. So we are checking the condition ptr tends to next is not equal to start. Yes, it is not equal to start. So if it is not equal to start means we have to execute the statement, that is ptr is equal to ptr tends to next. So we have to repeat the 7th step till this condition getting the false. So it is not a start node. Next node is not a start node. So the next node becomes a ptr. Then again we are checking ptr tends to next is start. It is not a start. So next node. Again we are checking the condition. Ptr tends to next is start. No. Then we are checking the condition ptr tends to next is start. No. Then we are checking the condition ptr tends to next is start. Yes, it is a start node. Okay. Yes, it is a start node. So the condition becomes false. So what we have to do, we have to go to the next step, that we are given ptr tends to next is equal to new node. Okay, so here I'm giving, for understanding, I'm giving some memory address, the memory address for this new node. So this is the new node, right? For this I'm giving the memory address 100, and for this I'm giving the memory address as a 200. Okay, so what will happen, for this also I'm giving for 150 I'm giving for this. Okay, so what is the first statement, ptr tends to next is a new node. So this is a ptr node, and next is this part, it contains the address of the new node. Previously it contains the address of this 150, now the address is 100. Okay, now the address is 100 here. Then next, new node tends to previous is equal to PTR. New node. So this is the new node tends to previous is a PTR node. So the address is here, it is 200. Then next, new node tends to next is a start. So new node tends to next. What is the start node? This is the start node. What is the address? It is 150. So it is 150. The next new node tends to next start. Then start tends to previous is a new node. So this is the start node and previous it contains the 100. Earlier it was 200. That is this address. Now it is new node address. So new node address. So it is 100. Then start is equal to new node. So now what you are doing? You are making this new node as a start. So by using this, what happened? The directions are changed here. Okay, so this is the method. So here I have given only the algorithm. Okay, so when I am writing the code, just I will write here. So first struct node. Here we have to use 2 pointers. So one is new node and next one is a 1 pointer variable, that is a PTR. Okay. Then next we require one variable for storing this value. So I am declaring one pointer variable int num. Then next we have to get the value from the user. So for displaying the statement, I am using the printf statement, the /n. Enter the data. Then by using the scanf statement, we are going to get the value for the num. Then what is the next statement? We have to allocate the memory space for the new node. So new node is equal to struct, that is node. Then we are using the malloc function, malloc size of struct node semicolon. Then next what we have to do, we allocate the same thing as it is in the code. So new node tends to data is equal to num. We are allocating the value for the new node. Then what we are doing, we have to assign PTR is equal to start. We have to assign PTR is equal to start. Then we have to check the condition. So the condition is while PTR tends to next, it is not equal to start. So this is the condition we are going to check. So if this condition is true, means we have to execute PTR is equal to PTR tends to next. Okay, so once this condition becomes false, we have to do the next step. So for that, what do you do? PTR tends to next is equal to new node. Okay, then new node, same as the algorithm only. New node tends to previous is equal to PTR. Then new node tends to next is equal to start. Then start tends to previous also we have to change, right? Start tends to previous is equal to new node. Then we have to assign the new node as a start. So start is equal to new node. Then we will return the start. So this is the code for inserting the new node at the beginning. So if you remember the algorithm means, this is the step you have to write which is not available in the code. Then other things are same as the algorithm. So if you compare and study, it will be easy. So this is the method for inserting the element at the beginning.